All right, so here we are in another Lab 1 tutorial. I believe this is number 5. So the link to the Oregon State University's PRISM climate group data for downloading kind of the normals seem to have not quite been captured perfectly. So I'm going to click on normals, which is what you want to download. And so we're going to try to get annual data for Utah on precipitation. And they have two spatial resolutions available, a 4-kilometer data or an 800-meter data. Our other grids are 2 kilometers. So you could choose either of these, it's fine. I'm going to choose the 800-meter because I think their data is better than ours. So might as well see something that looks a little bit better for comparison. And so I'm not after monthly data or daily data. So I don't want to download the full-size image. This is going to get the whole country, by the way. So we're going to have to clip it to the state of Utah. And they have two different file formats available. While this image is shown in inches, the data that you download actually comes in millimeters. So you could see that if you looked through their metadata here. Download, yeah, so if we look through their metadata, that should say that. If we look through here, so if I did like a control F millimeters, we can see the attribute is millimeters. Okay, so keep that in mind. I'm going to check myself on what download formats we have. So Bill is a binary raster data set, header, projection, etc. So so all download data sets are come as zip files, so we'll have to unzip them. Yeah, so we just have a couple of different types of grids that they're offering us. I'm not sure why it says download all normals versus download data. I mean, either of these should work. I'm going to download each of one. So the data ASCII and all normals ASCII and see what's going on there. Because it's not like I asked for a specific state, so I don't know why it's all normals versus. Oh, I know why, because actually there's all of these climate variables. So actually the download data ASCII for precipitation is going to be the one I want. And you can see, look, the other one is way too long. So we'll cancel that. Okay, so I've opened that zip file. I'm actually just gonna, this is not the way to do this, but I'm gonna cut this and I'm gonna move it to my other folder that I'm working in. It's in my teaching files. This class 3650. And so I'm gonna navigate all the way to my interpolation lab, and I'm gonna put it under outside data, not in the geodatabase. I paste it right here. So I just drilled into the zip file and grabbed everything. It's the same process as extracting it, I believe. Yeah, should have worked. Okay, so now we can go back to the lab and hunt for that data set. Okay, so we go add data, browse, and we want to go in our should be in, yeah, so I put it in that folder. So we can see that pretty quickly from our folders, outside data, and there it is. So we should add that. Failed to add the data. didn't like it. Maybe I want to have not done it the way I did, or maybe I'll try the other data. So let's save that bill file instead directly. Goodness. It won't let me save as. I got to download and then move the file. So if I go to my downloads, I should find the bill zip. I'll cut it, go back to where I was, outside data. And this time I'll just paste the whole zip file here. And then I'm going to right click and extract here. Okay, so now hopefully that bill file works. Binary interleaved something or other. I'll refresh this. Yes, there it is. This should load, hopefully. Yeah, that one's happier. Okay, there it is. The whole country's GIS data, of course. Yeah. The whole country's rainfall data. And you can just look at the fidelity of that. It really is mapped to topography really well. So it's going to look way better than our stuff, but we can see the units are different, right? The highest unit's 6210. It's definitely not inches, that's millimeters. Okay, so first thing I'm going to do is what's called clip raster. So I'll go to tools. Maybe it's raster clip. Type that in. No, it is called clip raster. So remember, I always like to look at data management tools, so see what else is in that area. So we're under data management tools, raster, raster processing, clip raster. So we're going to clip it by the state of Utah. But look at all these other cool tools that are in there. Split raster, resample raster, etc. So that's why I always just try to learn where things are in this toolbox, because we can find other tools that we might not have been aware of. So input our PRISM bill file, and we're going to output it Utah boundaries. But we have to check this box. This is the most important thing. Use input features for clipping geometry. Okay. So that's what's going to give us the cookie cutter shape. And output extent, output raster, we're going to call it, I'm going to call it PRISM 30-year norm underscore millimeter. Okay, run. Now I know what units it is in. Okay, so now the highest rainfall in Utah is 1661. We could also go to the symbology and map it to the symbology of these other ones, but I'm going to wait to do that, because to do that, first I'd like to have them in the same units. So millimeter or inches to millimeters. Let's see, inches per millimeter. So divide. So 1 millimeter equals that. So divide the length value by 25.4. So, all right. So if we go back to, so 1 divided by 25.4 times 1 is going to give us that number, right? So, okay. So we go back to here and we'll go to tools. And now I know what I want, which is called raster calculator, because we're basically going to do what's called a local operation, right? So we're going to go to spatial analyst. We're going to go to map algebra, raster calculator. We're going to input that PRISM millimeter value. So whatever value at that pixel, we're going to divide it by 25.4. Okay. So that's going to give us less than we originally had, which is going to give us our inches. So there's 25.4 millimeters in 1 inch. Okay, so our output raster, we're now going to call it, we'll call it PRISM underscore 30 year underscore inch IN. So it should look like the same thing in terms of like its symbology, and it does. So if you were just trying to visualize, wouldn't be a big deal. But so yeah, there it shows that the highest values of Utah precipitation get up to 65 inches per year in some parts of Utah. And so that's different than what we saw in our interpolation values or even on the rainfall values directly in the tables for the Utah norms. The highest we saw there for any gauge was less. It was like 57 inches. So why is that? Well, the PRISM data is doing an interpolation as well. It is based upon rainfall gauge data, but other things as well, including satellite remote sensing and possibly other data like snow surveys and things. So they shouldn't be exactly the same, and that's part of the reason we're comparing them. Okay, so I turned off my millimeter one. I'm going to even remove it just to be not confused. I'm going to remove this whole country so I don't have to look at that. And now I'm going to go to symbology here. And what do I really want these things to look like is a good question. So maybe before applying these other symbologies to this one, I'll see if I like a different symbology to begin with. Like maybe instead of classification, let's do a stretch where kind of goes from dry to wet or something like that. Let's try that for a second. That's maybe not showing enough differentiation, in which case I could look for something more varied like this, but invert it. Where is it? Taking a minute to show up. Let me turn off these other things. Yeah, so that looks kind of cool, right? You can really see the high areas of precipitation showing up in the mountains. And it's doing a percent clip. If I did like minimum maximum, it's probably going to look a little different. Doesn't look the way I want. So I don't really like that minimum maximum. Let's do standard deviation. I have a real hard time displaying these things. Standard deviation looks a little bit more saturated. But yeah, so that's one option, right? We could do something like that. It almost looks a little like a digital elevation model because it's so tied to elevation in terms of these precip values. Now I could also see instead if I like what these other things are doing. So if we want to import from a layer, we could do that. And so let's try that. Go back to the same kind of values we were using before. And yeah, so this is in terms of what we've been used to looking at, this is really maybe helpful, right? So you just see a lot more detail as compared to that 2022 information. Let's look at 2021. Oh, gotta turn it on. Just not as much detail there, huh? Norms. Yeah. So, it doesn't do, our interpolations are nothing like PRISM, but you can kind of see a ghostly image of what PRISM data has determined. Why not? Why aren't we as good? So if we turn on our Utah norms, we can see we just don't have data everywhere, right? So, some of this PRISM data has got really kind of high values in these mountains here. We have no data stations over there. Same thing here. And so maybe we look underneath there. Yeah, they just don't show up because there's no data coming from there in our interpolation. It's just the way it is, but you can see the gross pattern is similar. Okay, so I'm going to leave you to doing your own uh, cartography where you're going to compare these, make your own layouts. If you need any help with that, let me know. I'll show you something briefly here just to remind you. Right, to bring up a layout, we can make a new layout. And so, since we'll do side-by-side comparisons, maybe make it a little bigger. We're not printing these things out. It's up to you because you can always zoom in on them. But I'll just choose a basic thing here. So make a new layout, and then we're going to have to add in a new map frame, right? We only have one map frame to add in. So if you want to have 4 side by side, remember that you'll have to I think basically create a new map, right? So yeah, we'll go make new map, and then we'll go copy what we want from this map, put it in that map, and then when we go to layout, you'll see that we have other options. We have map, and we have map 1. And so then you'll be able to put each one side by side. The Kriging for normals, 21, 22. Okay, so other things to consider. Again, I'm not going to go into the details, but there are templates if you hunt around in here for your layouts. And so trying to remember, oh yeah, so we click here, import template. And so in here, you can see lots of different templates. This is for your whole layout. So if we wanted to find a particular template, we'd probably need to have a multi-map one. And I don't see that here. But if you do end up creating your own kind of really nice map that you'd like to make a template for, I believe you can save things as a template. So you could save that layout as a template somehow. So you might look up that if you really like what you've got in the end and you think you're going to make something similar in the future, saving a map template or a layout template might help you save time. Okay, but I'm going to close those, go back here. The other part of the lab, other than the digital elevation model information, and I'm not going to redo that for 2025's lab. You can just watch my 2024 lab video on that. But for the rest of the lab, I asked you to quantitatively, not just visually with your layouts, but quantitatively compare these different years. And so there's a few different ways we can do that, right? So first order, we can just go and directly compare things, right? If we went to the attribute table of 2022, and you look you right-click on it, you can explore the statistics for 2022. You can see that the mean precipitation was 17.9 inches, ranged from 2.7 to almost 50. It gives you standard deviation and everything. If we go to 2021, we can get that same information. So we can get statistics right out of the tables. And so we see 2021 had a little, stations on average had a bit more precipitation. The max was higher in 2021 as well. And then the norms, look at that. Again, same thing, just right click, explore statistics. This is a first order approximation. So you can see the mean is pretty close to both of those years. Other ways that we could do that would be to directly compare them. So for instance, we have the normals, right? And so if I just show you the norms in the background here, so these are the norms that we calculated. And so if we wanted to compare these points from 2022 to the values here, we could do that as a table too. So I'll show you that really quickly. So if we go to analysis, this is one tool you can use, which is called zonal statistics. And so that's found in a few different places. I like spatial analysts, so I'll go there. So we can get zonal statistics as a table. So the zone data we might be interested in would be so the Utah so Utah 2021 features, and the zone field that we might be interested in, say, object ID, right? So this is something that we could then pull back into the table for comparison. And we input the raster value from the Utah norms. You could also choose the PRISM data. So what this is going to do is going to look where these points lie, and it's going to pull out the raster value of those normals at that point. And it'll give us the statistics for that. And maybe we just want the mean, because it's actually at a point, so we're not going to get any statistics. It's only one value. And so just run that. And then we should give us a table, right? So if we open that table, you can just see that is the precipitation value that was interpolated at that point. And then you could go back to 2021 and you could do a table join, add a join, input field object ID, Utah, no, zonal. Zonal stats, there we go. Same thing, object ID, and we run. Now, if we go into 2021 data, should see, yeah, we've got those means, right? So then you can see the precip and the mean. You could save this. Remember that all table joins are temporary, but if we then export it as a new file and save, they will become permanent. We could then make a new column, and we could do the difference between the mean and the precip and see on average what it was and things like that. So that's another way through zonal statistics. If we wanted to have a map of spatial difference, then we can do raster calculator differencing. So I'll show you that as well. So if we go back to geoprocessing, and again, go to raster calculator, which is in spatial analyst tools under map algebra. And we could take what we see as the average, and subtract a year. So the difference between the average and the year. So if it's less that year, it'll show as no, we probably want to do the year minus the average, because then if the year was less, it'll show up as it was low precip negative. So yeah, we do 2021 minus, and I'm going to do the PRISM in this case. And so this output raster would then become 2021 diff normal, diff PRISM. How about? Oh, you should know that your output rasters in a geodatabase can't start with numbers. So we'll call it diff 2021 PRISM. Can have numbers, they can't start with them. Sorry, I made a mistake there. Now we should get a new raster where we should have negative and positive values. And so if we were going to symbolize that, we'd want it to go negative to positive. So like super dry to wet. And in this case, we want to invert it. So it was dry in northern Utah in 2021, and some other places were apparently wet, at least as terms of our interpolation shows, or relative to PRISM. If we ran that again on our own normal precipitation interpolations, we might get a slightly different result. If you don't like, this is kind of non-intuitive and doing it on a stretch symbology, so you might classify it. And then you could look at your histogram. You can see that 0 is near here, right? And so there actually is kind of like half of the landscape is negative and half is positive, maybe. Is that really true? So if we go show statistics, the mean is that it's a little bit more positive. So it was a little wetter than average in 2021 in terms of our data. But some of it's more dry. So there's areas with more dryness than there was more abnormally wet areas. So again, the histogram from these difference maps could be quite useful. And so you could then say, okay, well, doing natural breaks, that might be something. Instead, we could do equal interval, be another way to go. But then, it goes all the way out to 36. Maybe we don't want that. So maybe what we want is one of the breaks to be 0. Okay, so now we see where 0 really lies. And then maybe 10, and then out to the range. And then we could do 10, and then, yeah, a short 25. Boom. Okay, but then maybe we change this color. So we go back to classes. So we want the dry stuff to look super dry red, and then orange, and then kind of tan. These are all negatives. And then this one we might want green, light green. And blue. Okay, so that shows our wet areas and our dry areas, and then kind of our in between, right? Again, these could be artifacts of our interpolation, so keep that in mind. If we go in the histogram, we can see generally there is more areas of the state that show up as wetter in 2021 relative to PRISM. Okay, so yeah, a few lessons here, right? So we had raster calculator, differences. Look at that difference maps histogram, its summary statistics as shown here. Potentially classify it or stretch it to show the imagery of difference. Those are options. We can also directly compare through zonal statistics and table joins, or even table joins of the original input data for those differences. Also in the lab, I asked you to compare by elevation. And so there's a couple ways to do that. Actually, if you go back to, or to compare precipitation by elevation. So the simplest thing to do there is if you go to the attribute table for Utah normals, you see that you can see precip values, and it shows the elevation of those stations. So a real simple thing you could do is actually to create a chart, and specifically a scatter plot where you're plotting how precip varies with elevation. And so um, let's see, we want maybe precip versus elevation. You could do it either way, but there's a positive relationship. So the higher you go up in elevation, the more precip you get with some uncertainty. And so, yeah, you have a linear relationship. So as you go up, right, you're changing your precip on average, every, was that 40 meters? You're going up a little bit in precip. So yeah, you could do that. Maybe you could try it, see if there's a better relationship to be seen, a power law, polynomial, probably not. Is it exponential fit? It really looks like a cloud, so I'd probably stick with linear, right? It's kind of easy to understand. You can show the trend line, you can put the equation on the chart. Um, yeah. And then you could think about, why does it vary? Why isn't it just exactly following this trend line? Okay. Um, yeah, so you can compare elevations that way. You could precip versus elevation. You could also compare it to a digital elevation model that you bring in. So um, yeah, you have a lot of options. But the main thing I want you to explore in this lab is, how do I go beyond just simply visualizing these relationships to somehow quantitatively showing them, the relationship between elevation and precipitation, as well as the differences between wet and normal years, or dry and normal years. Um, so very good. I hope these video tutorials help you proceed with the lab, and let me know if you have any questions.